Okay. So, so I was just starting with the system and the classification of system, and there I talked about. So these are the system that we have talked in the previous sessions and all. I'll just be giving you the recap. So the first thing is the linearity. So for any system that has been given to you, you have to check whether the system is linear or not. So the condition that you can check it, if there are any operation on xt, okay, that will make the system non-linear. Any operation on xt will make the system non-linear. This is the first condition. The second condition is if there is any constant added to xt, that will make the system non-linear. Okay. So two things I told you. Any operation on xt, not on t, on xt, that will make the system non-linear. Or if you are adding any constant, that constant will be in the form of something like some constant, see, like 1, 2, 3, 4, 5, 6, or in, I'll just give you examples. Okay, that will give you an idea. So two things I told you: either any operation on xt or a constant, and that is added or subtracted. Okay, not multiplied. Okay, I'll just give you an example also. Let's, for example, you have. I'm just giving some example. X cube. Okay, or sine of xt, log of xt, exponential of xt. Okay, mod of xt. What are the system? If you have been given the system, what are this? These are non-linear. Okay, so you can see that there are some operation that has been done on xt. So this is x cube. Okay, here also there is some operation that has been done to sine of xt. So that makes the system non-linear. This is also non-linear. This is also non-linear. You can check it from there. So if you'll just apply the additivity and the homogeneity, it will not follow. So so I guess you can just check it. Is this clear to everybody? Are you able to understand this?
Yes, sir.
Yes, sir.
Right. Okay. Can you just tell me whether this, what about this system? Is this system a linear or non-linear? X of t cube.
This is linear.
This is linear because I told you, right? The operation on x will make the system non-linear, not on t. Okay. So similarly, if you have a system x of sine t, this is also linear, right? X of mod t is also linear. So the operation on t doesn't make any impact on the linearity of a system. Okay. X of exponential of t, that will also not impact the linearity. Okay, I hope this is clear. So the first condition that I told you, right? So this blindly you can just whatever the function has been given to you, you can directly check it whether the system is linear or non-linear. I hope this is clear. Now the second thing that I was talking about. Yeah, there are some exceptions also. The exceptions are, there are only two exceptions. The differentiation. This is also you are doing some operation on xt, but that will not make the system non-linear. This is a linear system because you can check the additivity and homogeneity. If you will just apply some, let's for example, a times x1 t plus b times x2 t. So that will be getting the same things. D by dt a times x1 t plus b times d by dt x2 t. So both are equal, right? So this is following additivity and homogeneity also. So this is linear. So there is only two exception. One is the integration and the second differentiation, and the other one is integration. Here also the homogeneity and the additivity follows. So that's why the integrator and the differentiator are always linear. Clear? There was only two operation exception for this. Now the second condition that I was telling about, if you are adding some constant, okay, that will also make the system. Let's say example, the system is xt plus 5. Okay, this will also be, this 5 makes the system non-linear, even though this xt or let's say example t plus 5, y2 equals to t plus 5. So this 5 will make the system non-linear. You can try it out with the additivity and homogeneity also, because you can see that this t plus 5, and again let's for example you're just multiplying with 1, or again let's for example is a system, right? You are applying t plus 5, again t plus 5. Okay, and the constant that you are multiplying is 1 only. That also, it will make the system 10t plus 10. But if you directly transform, it will be something like 2t plus 5, right? So both are not equal. So this also doesn't follow that the additivity and homogeneity. So this is a non-linear function. So t plus 5. So t plus 5 will make the system non-linear. This 5 will make the system non-linear basically. Okay, the constant will make the system non-linear. So whenever you are having any functions, that is xt plus c, this is non-linear, or xt plus anything t, let's for example, okay, that will also make the system. So here the t will work as a constant, so they will also make the system non-linear. Okay, or xt plus cos t, or xt plus log t, whatever you want to call it. So if there is something that has been added here, right, not apart from xt, okay, let's for example, this is xt plus 5xt, so there is 6xt, right? So that is, if xt is linear, this 6 times xt is also linear. Okay, but this xt is linear, but there is some constant has been added, maybe c, t, cos t, anything. Okay, apart from this function itself, will make the system non-linear. Any confusion anybody has, you can just let me know. No, right? Okay, so now, and one more thing, there is no impact of, there will not be any impact of scaling and shifting on the linearity of a function of a system. Okay, so any system, let's for example, xt was linear, x of t minus 7 is also linear, x of t plus 7 is also linear, x of t by 2 is also linear, x of 2t is also linear, x of minus t is also linear, 3 times xt is also linear, minus 1 times xt is also, everything. So no impact of uh, scaling or shifting on the linearity of a system. Clear?
Yes,
This
sir.
is clear. Yeah. So okay, if this is clear, just let me know what about this function, this system. Is this a linear or non-linear?
This is linear.
This is linear, right? Because I told you this t can come as a multiplication. Not, it should not. If this was xt plus t, then this was non-linear, but this is linear. Okay. I hope this is clear.
Sir, limit comes in the first section also, right? The differentiation and integration one.
Which limit?
Uh, Whenever we have something limit k tends to infinity, something like it. So it get distributed also, right?
Okay, but those things I don't think so. You have to study. I guess you are talking about the accumulator. In the accumulator, when you are dealing with the discrete value, there the accumulator comes into picture. That is what you're talking about, or something else?
No, like if we have some function like y of t is equals to limit something tending to x of t, then that would be
Huh.
linear also, right?
Yeah, yeah, that also can be linear.
Yes.
Okay. Yeah, I'll, if you have any function, you can just let me know. But okay, as of now, I
Sir,
hope
what about the integration function?
yeah, integration, integrator, and differentiator both are linear. Those are the exception that I told you. Because if you do any operation on xt, that will make the system non-linear. But integrator and differentiator are uh, exception. And also, I hope you are aware of the integration are generally two types. There are generally two types of integration, right? One integration that you directly write it as minus infinite to infinite, right? Then you integrate it. This variable generally you write it in the form of a t. This is nothing but the area, some fixed value you'll be getting. But let's for example, if you are doing something like t to t, right? Minus infinite to t, there the you generally change the variable, right? It will be something like x of tau d tau, correct? So this is a different integration. So let's for example, xt here was ut. So what you will get? A ramp function, correct? If it was a delta function, you will get a unit step. But if it was just to infinite, minus infinite to infinite, if you are integrating ut, you'll be getting infinite. So there are generally two types of in this integration. I hope this you already know. And many a times, depending upon the limit value, the system will change. Whether many a times it can be. We'll talk about that, the causality and non-causality. Many a times, what happens whenever you do the scaling, the system generally the the character of the system generally changes. Okay, so whenever, let's for example, there is an integrator x of tau d tau, okay, minus infinite to infinite. Okay, So this was, let's say, example causal or something non-causal. But when you do the scaling, so scaling can be of two types. Scaling also can be represented in the form of a two types: minus infinite to 2t, and then x tau to d tau. Also, this is also what the scaling with two times. But if somebody write it like that, also this is also scaling only, del of 2 tau minus infinite to t. So I'll talk about this, but I'll go into that. So linearity is clear, right? Everybody? No
Yes, sir.
confusion in that? Oh, okay. This is the last question. Let's say example you have x of 2t times x of t. Is this a system linear or non-linear?
Non-linear.
This is non-linear, right? Because this gives you an impact of x square, right? So there is operation, so that will make the system non-linear. What about this system? If x2 is linear, what about this system? Is it linear or
Linear.
non-linear? This is linear, right? Because you are just doing the differentiation, double differentiation on xt. If single differentiation, double differentiation, that is not going to make any impact on the linearity of a function. Okay. What about this?
Non-linear.
Non-linear, correct? So this is non-linear because we are just doing the square of xt. This is clear, I guess. Xt times ut and xt plus ut. What is this?
First one linear, second one non-linear.
Non-linear. Anybody else has any doubt? Whatever we have discussed till now, I don't think so. These are very basic things, right?
So Sonali wanted to ask something.
Yeah, Sonali, go ahead.
So basically for the integration and differentiation for all the functions is a linear, right? So
It's
irrespective
linear.
of the integrations, limit of
Everything is
integration.
linear. Yeah, everything is linear, but only thing is you have to check whether, if let's say example, this is the way the question, the system has represented. This is not linear, right? Because it's the square of that system. So this will make the system non-linear, correct? But even
Yes,
only
sir.
integration and differentiation is been written, you can mark it as a linear system. Okay. Prima facie, you can mark it as a, but what else has been given? That also makes changes, but most likely it will be linear. But let's say example, you have some operation has been done on that. So that will make, can change the linearity of a function. But mostly if just differentiator and integrator has been given, you'll learn it in the analog and all. Whenever you have an integrator or differentiator, it will be a linear system. That is how generally we work, right? LTI system and all. LTI is like linear and time invariant, right? So that
Yes,
is how
sir.
it works, right? Yeah. So whenever you build an integrator or differentiator, right, with the help of a capacitor or whatever, some devices. So there, that is how this system. Otherwise, if it was a non-linear, then so everything would have been like, it would not have worked. Okay. So that's why the linear and the integrator and the differentiator will work as a linear system. Okay, always. Clear? Can we go to the time invariant and variant?
Yes, sir. Thank you, sir.
Okay, thanks. So time invariant and time variant. Everybody knows that. So this is nothing but if you are doing delaying the input signal and delaying the output signal, if both are same, then you call it as a, there is no changes in the, so that you call it as a time invariant, and if there is some changes, then time variant. Okay. So there is also very nice trick, not trick, but it's like people call it as a trick. So if you have any operation, right? So this also, any operation on t here. Earlier I have studied any operation on x will make the system non-linear. Here, any operation on t will make the system time invariant. Okay, any operation on t will make the system time variant. Okay, so let's for example, if yt are this function, you just have to tell me whether these are time variant or time invariant. Okay, tell me first one. What is first one? Time variant or invariant? Any operation on t will make the system time variant. Are you
Time
agree with
variant.
time variant? Okay. This one, x square,
Time invariant.
invariant. Time invariant,
Time invariant.
operation on x, correct. Okay. What about this?
Time invariant.
This is not time invariant.
Time
This is time
variant.
variant. Yeah, operation on T. Okay, will make the system time variant. Huh? Similarly, operation on T will make the system time variant. Is this clear? Operation,
Yes, sir.
anything that you are doing in T. So scaling, you are doing any operation, any logarithm function you are applying on T, that variable that will make the system time variant. And that is, you can see it also, right? Because when you delay the signal in the input, right? If you delay the signal in the input, everywhere you have to replace T with T minus maybe capital T. And if you delay the signal by the output, you just have to put only one T, right? So any scaling or any operation on T for sure will make the system time variant. Is it clear to everybody? Are you able to understand?
Yes,
Yes,
This was
sir.
the
sir.
this was the first thing. The second thing, okay, let's say example, whatever system that has been given to you. If you see the variable T apart from, so if your system xt has been given apart from here, if you see that the variable T anywhere else, then directly you can make the system as time variable. Okay, let's for example this one. You can see this variable apart from here also, right? So that will make the system time variable. Okay, and that is very evident also because whenever you will do the input delay, so you'll at every T you'll make T minus tau, correct? But if whenever you'll do the delay in the output, you'll just make it here T minus tau, so that both are not equal, so that will make the system time variant. Okay, clear? So two things I told you, right? One thing, operation on T will make the system time variant, and operation. And if you see the T, this variable, apart from the function, whatever the system has been given to you, apart from there, if you can see this variable anywhere else, you can just directly make them. Blindly, you can mark it as time variant. Okay, clear? Clear. Okay. Okay. So now I'll just make it some notes. I'll just make a notes and then upload it also in the group. That also you can read it. If you'll just go through that also, it'll. So what are the factors that will affect time invariant? Huh? And factor affect linearity of a function, right? Just give me 1 minute. Okay. So where was I? So factor affecting time invariance, and so you already know that any scaling will affect. So scaling will affect. Okay, scaling will make the system x of 3t. Okay, or the first one. The second one is any operation on t, right? So generally x of t square, x of mod t, t times xt, right? Operation on t, or you are able to see anywhere else the t, you can directly mark it as uh, time variant minus t. Hmm. What are the factors that will be having no effect on time variance invariance? So any operation on xt is not going to make any difference on the time invariance and the time variance of a system. Okay, so the operation, no, there won't be any impact. And the shifting, so the shifting will not have any impact on the time variance or invariance of a system. What about this? In the linearity, what you are reading is any operation on t will not have any impact on the linearity or scaling. Scaling will not have any impact on the linearity. Shifting also will have no impact. And the exception I told you already, the differentiation and the integrator. Okay. And the factor that was affecting was some constant, if the constant is added, or operation on xt. Okay, that summarizes whatever we have read till now. Clear? Okay, so if that is clear, there are some the question that can be asked in your exam. t square xt, first one. Second one, t times mod of xt. Third one, mod of xt. You have to tell me both. X of t minus 5. Fifth one is max of 0 comma xt. Yeah, tell me. So if everybody, I guess, have understood, you can just start telling me from first one.
First one, linear and time variant.
Linear and time variant, correct. Linear because so t doesn't make any impact and xt is xt. So time variant because you can see t apart from xt. What about the second one?
Same.
Same linear, time variant.
And third one, linear and time
No.
invariant.
Okay, the second one is
will be non-linear.
non-linear because there is an operation on x, right? Okay, there is an operation on x that will make the system non-linear. Here also, this is non-linear. What about the time? This is time invariant, correct?
Yes, sir.
Clear? No. What about this? This is linear and time invariant.
Variant.
What about this one? So there is some operation on xt, right? That will make the system non-linear.
Sir, in the fourth, there will be a time variant, right?
Why
There
time
is
variant? X of t minus 5, right? Shifting doesn't impact anything. Shifting,
Oh.
I told you, right? Shifting has no impact on the system, linear time invariant.
Only.
Scaling, only scaling will have an impact.
Okay.
Okay. What about this maximum? So you are doing some operation on xt that will make the system non-linear. What about time invariant?
Time
That is not going.
invariant.
Time invariant. Anybody has any doubt in this 5? I'm damn sure you'll be getting some 5 questions from the system itself. You have to just pick out. It'll be a combination of something, like some function will be given, and then you'll have to mark it out of this 4, which of the combination are correct. And the combination can be a linear, time invariant, and causal. So this type of combination will be there. Okay. So this 5 is clear. The last one is clear to everybody.
yes, sir.
Okay. Let's go to the next part. Now the remaining part are very simple. The causal and the non-causal. Okay, so this causal, non-causal you would have studied in for the signals also, right? For the signal you would have studied, right? The causal. What are causal signals?
Which depends on present and past.
No, signals, only signals. So whatever you're talking about are system. If you have studied about the causal signal are those signals which are purely right-handed side defined, right? So right-handed signals, okay. And what about the non-causal, which are not causal? These are, I'm talking about the signals, okay. And whatever the anti-causal are opposite of causal. Okay, these are signals. I hope if you have not studied, I hope in the classification of signal this was not discussed, right? So if this was not discussed, will not be asked. But yeah, we'll be asked about systems. So the causal system. So whatever Ananya was saying, right? That is correct. So that will live in the only the causal. Whatever the causal system.
Which depends on present and past.
That depends. Okay, you can just write it as doesn't depend on future. Okay.
Excuse me, sir.
Yeah.
What does it mean here, the purely right-handed side?
Purely right hand side is, for example, a UT function, UT signal. Okay, it's just right hand. So only defined in t greater than equals to 0. Those are the causal signal, not system. Signal, causal signal. Huh? So the causal, there are signals also. So causal signals are those signals which are just defined in, just defined for t greater than 0, right-handed signals that you call it as. Okay. But when we talk about the system, in system there's a different definition for a causal system. Okay, so the causal system are those systems that doesn't depend on future. So that doesn't have any impact, like dependency on the future. That means it can be present or past or both. Okay, any system that contains, let's for example, a system yt equals to x of t minus 2 plus x of t plus 2. Not, again, this is a future thing, right? So present, this is present, this is past. Okay, there will be a causal system. Is this clear to everybody? The causal system signal, leave it signal, because I hope that is not discussed. And even though if it was discussed, it will not be asked in quiz 2. Okay, system is this. Yeah. Okay. What about the non-causal? That depends on
Future also.
future input. So the causal system, if we have been asked, those system which doesn't depend on future. So it can be past, present, or both. Not future for sure. If it is future for sure, you go with non-causal. Now there is something else, static and dynamic. What do you mean by static?
Which only depends on present.
Present. Only present. So that word only is important, present. So there should be only present. That means what? It should not be having memory. Okay, this system should not be having, doesn't have memory to store the past or the future thing. It just work on present. Okay, so this is memoryless. Doesn't have any memory to store past or future data. Dynamic is the memory, having the system with memory, that you call. Okay, is it fine?
Yes, sir.
So yeah, should be having, okay, then my pen is not working. Okay. Past or future or both. Is it clear to everybody? Okay, now you have
Yes.
to tell me, you just have to tell me whether the system is static, dynamic, causal, non-causal. You don't have to tell me time invariant, variant, and linearity. So these are the question. First question, x, and the second system is square root. Yeah, tell me the first one, the second one.
First one non-causal and dynamic.
Correct. Dynamic and non-causal. Yeah, anyone else is having any doubt, you can just let me know. I'll just explain that. So how that is dynamic? Dynamic is something that depends on past or
Future.
future. Okay, so you can just check this. Y of 2 is depending on 4. So future comes, right? So if future comes, for sure it will be dynamic, and if future comes, that will be non-causal also. Similarly, x square t. What about x square t?
Causal
Because
and
this,
static.
correct. So this is static because that just depends on the present, right? And then it will be causal also.
Sir, can you explain this too? I didn't get.
The first one,
Both.
okay. Okay. So the first one is yt is equals to x of t square. So I told you something. Static. If you have to check whether the function, the given system is static or dynamic, if only present terms are there, because static can't store any future or past things. Okay, so only present is available, then you can directly say that it's a static. Otherwise all the cases are dynamic. Okay, and the second thing about the causal and non-causal, if we are able to see some future thing, okay, you can directly call it as a non-causal. I hope that is clear. Now y of, I have to think of y of t. Y of 2 depends on x of 4. That means what? This function depends on some future values, correct? So y of t, so it depends on the output of second value, the t equals to 2 value depends on the fourth value, so, right? So it depends on some future value. If there is some future term, what do you call? So some future terms means what? It needs some data to store, right? So if you need some data to store, that means some dynamic for sure. And future terms comes, that means what? Non-causal. Okay, I told you, right? It has been written here. Non-causal depends on future input. If there is some future term, you can directly mark it as non-causal. Clear? Now go to the next one. Yt equals to x squared t. See, yt equals to, you put 0. It will depend on 0 only. Y of 1, it will depend on 1 only. So that means what? It just depends on present. If a system just depend on present, that means what? It is static for sure and then causal also. Is this clear? Yeah. See,
Yes, sir, clear.
yeah. So let's say example, if only present is given, right? If only present is given, then for sure it will be static, because present means what? No data. You don't need data to store. So only present, static. Otherwise, all the cases are dynamic. Else, dynamic. Okay, the first case. The second case, if you are able to see future thing in the system, for sure it is non-causal. Else, it is causal. Okay, there's two things you can see. If present, you are able to see static. Otherwise, all the cases are dynamic. If you are able to see some future thing in the system, you can directly say it as non-causal. Otherwise, it is a causal. Okay. Now, examples, you can just mark it, practice it. X of t plus 3 is present, future, t minus 3 plus xt, xt plus x of t plus 3, xt minus 3 plus x of t plus 3, and then you have xt minus 3, x plus xt plus x of t plus 3. Yeah, tell me from starting. Okay, this is future. Okay, future means what? You need something to store. Pakka dynamic, right?
Yes, sir.
Okay. What about the causal, non-causal? Non-causal, right?
Yes, sir.
Okay. What about this one? X of minus
Non-causal
3. Non-causal,
and dynamic.
dynamic. T by 3. Non-causal or causal?
Causal.
This is non-causal.
How?
Okay. What do you mean by non-causal? Depends on future. Put y of minus 3 will depend on x of minus 1. Future, right?
Yes, sir.
Okay. See, you can have an, so non-causal means what? If you are just able to get one term as a future, that's it. That's a non-causal. Okay.
Yes, sir.
Yeah. Anybody else has a doubt in this? Any scaling, if you are doing scaling, right, blindly you can mark it as a non-causal. Because scaling, you can put some values that will, so that let's say example it was t by 3, right? So people generally will think of as any positive value, and it will always be some past thing, right? So that future perspective will not become. So you just put it as some negative value, and then you can see that this also depends on future, and then it's a non-causal. Anybody else has a doubt? What about this? This is a dynamic or static?
Dynamic.
Dynamic, right? So because what about x of t minus 3?
Causal.
Causal
Dynamic.
and dynamic. Dynamic causal.
Static. Causal.
Future, right?
Non-causal. Dynamic.
Non-causal, dynamic. Past and present. Past, present.
Causal. Dynamic.
Past, present or future?
Non-causal. Dynamic.
This is past and future. Future comes
Non-causal.
dynamic.
Dynamic.
Past, present, future, everything.
Non-causal. Dynamic.
Anything, anyone has a doubt in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tell me. Are you able to understand it, or I'm doing very fast? Because I just have 1 hour, right? So I'm just going. But you have a doubt, you just let me know. Anybody has any doubt in this? No? Okay. If you don't have a doubt, let's move. Stability
Excuse me,
and
sir.
yeah.
I saw the example which you have given right now. The most of the examples in which the non-causal is a dynamic, so we can conclude that the a dynamic system is always be or
No,
is a
no, that you
non-causal.
can't. No, no, that you can't conclude. You can't conclude that because you can say that non-causal and dynamic are coming because non-causal generally depends on future thing, and whenever the future things comes, there can be a dynamic, but dynamic depends on past and future both, right? There can be some system which are just depend on the past, right? That can be a dynamic but causal, right?
Yes, sir.
Are you getting it? Yeah. There is no system that are dynamic and causal. Is there, right? You can see this fourth one.
Yes, sir. Only the in two examples is there where the dynamic and the causal,
Hmm.
but most of the cases in which the dynamic and the non-causal.
Yeah, but we can't conclude, right? Even one example exception that we can't conclude. But you can just remember, it's simple to remember, right? So dynamic means what some storage is needed, right? Any past, present, anything comes, past, future, anything comes, that will be dynamic. But for causality, for non-causal, you just need future things, right? So that is how you can remember.
Yes, sir. Understood. Thank you, sir.
Yeah, thanks. Okay, let's move to the next part. The next part is stability. So only two things are remaining now. Hmm. Stability and instability. Okay. Stability is pretty simple because stability, whenever you have to check it, stability, stable system or unstable system, correct? So in the stability or instability, right? So whatever we have to discuss, whatever we are discussing the system, in that system, we are just putting the input at some bounded input. And this bounded doesn't means we are not talking about the boundness in the time. Okay, we're just you are talking about the boundness in the magnitude. Okay, so in the magnitude we are talking about, not in the time variable. Okay, so if somebody asks you whether ut is a bounded or not, so this is bounded, right? You can see that the magnitude is bounded. We're not talking about the time boundary. Okay, so if let's for example somebody asks you what about the ramp function, is the ramp bounded or unbounded? Is the ramp unbounded or
Unbounded.
bounded? Unbounded, correct. Because you can see that as the time tends to infinite, the value will infinite, right? So the bounded means in the term of a magnitude. So whenever you are checking the stability of a system, so that's why you call it as a BIBO, right? Bounded input. If you are putting bounded input, you should be getting bounded output. Anything, let's for example, you are not putting bounded input. Let's for example, you are putting ramp inside the signal system. It can be anything, bounded output or bounded input, bounded or unbounded out. That we are not talking about. We, whenever you have been asked whether the system is bounded in, like system is stable or not, you don't have to check for all the cases. You just have to check by putting bounded input. Okay, whether you are getting bounded output or not. You don't have to put like ramp, like unbounded input. So I guess that is clear. So whenever you have been asked to check the stability of a system, you don't have to put any random input. You just have to put something that is bounded. Let's for example a unit step function. Okay, those things you can put it, or maybe a sinusoidal function that is also bounded because sine just oscillate between 0 to 1. Okay, so that's the value is bounded. The value, the magnitude is bounded. So I'm not talking about the bound is in the time variable, just the magnitude. Okay, is this clear? At least this much is clear, right? Whenever you check the stability, you always have to check with the applying the bounded input, not anything else. Huh? Okay, so for
So,
stable, yeah,
in the professor's lecture, sir took it as y of t is equals to x of t whole square. So how that is stable, because it is turning out to be parabola and it is going to infinity.
okay, so what was that signal? Yt equals to x
X of
square.
t is, yes sir.
This signal, huh? Okay. Let's say example, you are putting a bounded input. Bounded input is, let's say example, you're putting some sinusoidal or whatever you want to. If you're putting bounded input, bound some fixed value, let's say example, you're putting some finite. So the square of a finite will be a finite, right?
Yes sir.
Are you getting? So that is how it is stable. See, what
Okay
I
sir,
said
got it.
is, you got it, right? So any system that you are putting some finite value. Infinite you can't put, because I already told you the stability that we are checking, we are giving the input only finite value. So that's why we are checking BIBO, okay, stability, bounded input and bounded output. Okay, we are not checking all the combinations. This stability can have a n number of things, but in that n number of things, we are just worrying about bounded input, bounded output. That means we will just put bounded input, some finite value will be putting. Okay, so x square, we are just putting some, let's for example, some finite value. If we'll just put finite, finite square is also finite. Okay, it can't be infinite. So that's why this x square is a stable, BIBO stable. Huh? Clear?
Okay sir.
Clear with everybody, right? So now, if you are understood, tell me whether this is a stable or not, e to the power xt, stable or not, t times xt, stable or not, x square, stable or not, t times x square, stable or not. Tell me the first one. If you are putting some finite value here, will you be getting the output as a finite or infinite?
Finite.
Finite.
Stable. What if you are putting some finite to the like exponential ka power? If you are some putting finite value, will you be getting some finite or infinite?
Infinite.
Infinite.
Hey, how infinite? You are putting e to the power some 5, e to the power 10, e to the power 20. Some finite value you are getting, right? You're not getting infinite, right? So stable. Correct? Is it correct or not? Second one. Is this clear to
Okay sir.
everybody? So exponential has some function, right? Some curve, right? How do you represent? This is how it goes, right? So you'll be having some value, right? So some t ka value you'll be putting. So exponent x ka function will be finite. That is what I'm talking about. X will be finite, bounded input. Okay, so bounded input will give you a bounded output. If this xt was infinite, then you'd have got infinite. But that we are not talking about, because xt should be finite. That is the condition that we are putting. Then only it is a stability or instability you are checking. Okay. What about the third case? If you are putting a
Stable.
finite value, not stable, because xt is finite, but this t can be infinite, right? T we are not. Are we putting any limit on t? No. We just kept limit on xt. Are you getting me? See, this is a signal. This is a system xt. Okay. This is a system t times xt. We are putting condition on xt. This input is xt. Okay. This is finite. That's fine. So t times finite value. But I don't know. This t can be infinite, right? This infinite times some finite value will be infinite. So this is unbound, unstable. This is unstable for sure. Whatever we are putting just condition on xt. We are not putting anything else. We are just putting condition on xt that xt should be finite. Okay. Whatever the fourth one, this we have already talked.
Stable.
Stable. Yeah.
The
What
next
about
one is
this? T times
unstable.
x square.
Unstable.
Unstable. Right? Okay. Anyone else? Anybody has any doubt in this? Okay. If you don't have, tell me. E to the power minus t xt. What is this?
Unstable? No, stable.
Unstable, because this is finite, but this t, if I'll put infinite minus infinite, this will be an infinite value, right? So infinite times finite will be infinite.
Sir, it will tend to 0, right?
No, if I'll put t times minus infinite, t of minus infinite will be minus of minus infinite e to the power infinite.
Okay sir.
You got it, right? So
So,
t can be
Sir,
anything, right? Yeah.
In exam paper, it's given the limitations in the x of t or the functions which is multiplication
xt,
of that
just xt,
xt.
because we are talking, yeah, the system that we are talking about, there is a limit on input value. Okay, the input should be bound. So that's why a bounded input. So the input should be bounded. What is the input here? Xt is the input, right? And yt is output. This system can be anything. This is system is the transform xt times xt. This is a transformation. So the output is what? T times input value. This input is bounded. That condition we are putting. But this t, we are not putting any condition. This t can be anything, right? So that is, this t is a variable, can be infinite, minus infinite, anything. It should be, if it is a stable, then it should be a finite value. T times xt should be finite for all the combination of t. Is this following? No, right? T can be anything, infinite, finite, any number. So that's why this is a unstable. Yeah.
Sir, what
And
about
Go
what
ahead.
happen if it is given
What
that
happened?
the t is also be a limited values?
Then it's
So
a finite
at
value.
that time,
But
it's
that,
a stable.
yeah, that time it's stable, but that will not be asked, right? Why will they ask like giving t as a some finite value? They'll not, right? Because xt, that is like xt also, they will not write it. They'll just tell you, like they'll ask you like, is this a beaver stable or not? Like bounded input, bounded output stability or not. So that means bounded input itself means like you're just putting some bounded, some fixed value you're putting as an input. Okay, and that output should also be fixed. Okay, and apart from this, you have, if you see that t or anything else, this can be constant. Just for example, this is constant c. If this function was c times xt, c is some constant. What do you think? What will be the whether this function is bounded or unbounded, stable or unstable?
Unstable.
This is stable, right?
Stable.
This c is some constant, right? C is some constant. It's kind of 5, 10. It can be infinite, right? This c is a finite value. This c is a constant. Constant means some fixed value, right? Let's for example 5 times xt. These are unstable or stable?
Stable.
Stable, right? Because this is 5, some finite value, and next is also finite because this too you already know that this will be finite for sure. So that's why it says stable. Yeah. Any other doubt? Anyone?
Sir, can you take one that integration question
Okay.
of
Yeah.
C?
Let's deal with that. Mm, okay. So any integration. Let's for example, I'm taking this x of tau d tau. What do you think? Is it stable or unstable?
Stable.
Not
Stable.
stable. Not stable for sure. Xt. Just take xt as some bounded input. Take ut. Ut is in bounded, right? Unit step. If you just integrate the unit step, what will happen? Ramp.
It's a ramp
Ramp.
function.
Ramp is bounded or unbounded?
Unbounded.
Unbounded.
Unbounded. That means unstable. Remember it. Integrator or differentiator is always unstable. Whatever it is. Okay. If you are getting confused. Let's for example, so I told you for integrator. Let's for differentiator. xt. What do you think? I told you, right? Unstable. Now you take any xt. You take, let's say, unit step. Same unit step. Unit step is a bounded input. If you will differentiate, what will you get?
Delta T.
Delta function. Delta is what? Unbounded, because at t equals to 0 is it infinite. So it is also unstable. So both integrator and differentiator are always unstable. Okay.
Okay, sir.
Yeah. Okay. Now if you have understood, you solve this problem. Uh, Minus infinite to t, x of tau delta. This though I have already told you, but you have to tell me the causal, dynamic, and stability, all three. So stability, causality, say stability, causality, and this static and dynamic also. Static and dynamic also. All three you have to tell me for this function. I'm telling you first one. Second one is minus infinite to 2t, x of tau, del of tau. Third one, minus infinite to minus t, x tau, d tau. Oh, tell me.
Static and causal.
Static. Static, yeah, causal is fine. Static or dynamic? Unstable for sure. What about this one?
Non-causal.
Non-causal, correct.
Unstable.
Unstable, all three are unstable. This is also dynamic.
And
Non-causal.
third one is non-causal also.
Yeah, the
So the
first
first
one.
one is also dynamic.
Why?
So the first one is also a dynamic.
Oh, I'm asking why. Why is that dynamic?
It's depend upon the future and the past values.
Mm, yeah, I guess it will be. Think so. It will be dynamic because it is depending upon the past, right? Minus infinity to t. So it will also be dynamic. Yeah, this is dynamic. Correct. Nice. Yeah, the fourth. So what I can tell you, blindly what you can mark if you are just seeing the integration, not integration. You can just mark it whenever you are saying scaling is there, right? Blindly you can mark three things. What are the three things? If there is a scaling, what you can mark it? Non-causal for sure. Dynamic also you can mark it directly, and time variant. Okay, three things you can mark it. If scaling is there, okay, in the question, if options contains non-causal, dynamic, and time variant, you can just mark it blindly. You don't have to even check it anything else. Okay, is this clear?
Yes, sir.
Okay, so let's some you can practice this some question. X of cos t. Tell me whether this is a tell me linearity, causality, and memory less. Linear or non-linear?
Linear.
Linear. Causal, non-causal. Check for y of minus pi by 2,
Non-causal.
non-causal. Because y of minus pi by 2. Check y of minus pi by 2 will depend on x of 0. So this is non-causal and dynamic also. Correct? Right?
Yes, sir.
And this is the last function that we are doing today, x of t. Okay. Linear, non-linear. Non-linear. Causal, static. Depends on t, only present. Huh? That's it. Okay, invertibility, non-invertibility, I hope you already know that. So I am not discussing that. But yeah, anything else, anything that you have doubt from today's session, just let me know. And I'm telling you, you'll be getting some 3, 4 questions for sure in the exam. Huh?
Sir, can you discuss one invertibility question?
Invertibility, okay. So see, any system, you already know that, right? If one function, if you are able to see that the function that is given as a one function, you can find out the invertible, like inverse of that, right? So inverse of means see any system, right? Any function that has been given to you. If let's say example for that function, there's no trick as such to check invertibility. But see, invertibility is something like you have a system, right? And double system. So if you have some function and then inverse of that function, inverse system, and the subsystem is there. If let's for example, this is x cube. If you are putting minus 2 here, here it will be minus 8. If you are putting minus 8 here, it should be minus 2 only. If you are able to find it, that type of a system, right, then this is a inverse. So that's why x cube is a inverse system, okay? But let's, for example, x square. If you are putting minus 2 here, you are getting 4 here. But 4, will there be a system inverse of this that will give you minus 2? No, right? It can give you 2 or minus 2. So that means what? X square is not a inverse function system. Huh?
Okay, sir, I have one question. Can you take that
Yeah.
one? It's
Mm-hmm.
y of t is equals to uh, cos x of t plus c
Cos x of t plus c. Yeah.
is equals
This
to
is the system.
y of t. This x of t plus c is in cos of.
Yt equals to cos of xt plus C.
Yes, sir.
Okay. Then what is the question here? What has been asked?
If the invertibility exists or not. In the lecture, sir said that invertibility doesn't exist, but we can write this thing in x of t form, right?
What?
We can write this whole thing in a form of xt, but in the lecture, professor said that it is not invertible.
It's not invertible because see there are a lot of values, lot of t where you'll be getting the same output, right? Because the cos, see, leave apart this xt plus c. This cos value will be having, see, you can just think of as a cos function, cos of t. Is this system invertible? I don't think so. This is invertible. Why? There is a reason also. See, if you have a 1, 1, what are those 1, 1 function? If the horizontal line test passes, right? So there is some function. There's some function where if you just draw a horizontal line, right, it should not cut more than once. Okay, for this cos function, it will cut at n number of times. So this is not 1, 1 function. So that's why you can't get the reverse. So you can't get the inverse for sure. Are you getting me or not?
Yes, sir. Yes, I got it.
You got it right. So for some t value, right, you can get some cos ka value. But so let's for example, what are those values where the cos is 1? There can be n number of values, right? Are you getting me? So
Yes,
see,
yes.
what are those? Yeah, you got it. So you can't trace back. So invertibility is like you have to trace back the t. If you have the yt, the function output, can you trace back the input? So here, let's for example, you have the output as output of this signal, okay, is 1 or 0, right? So cos ka value can be 0 at a lot of like input, right? So here also it can be 0, here also it can be 0, here also, here also. There can be n number of values where the cos ka value can be 0. Can you trace back one up? No, right? You can't trace back. Which value tends to 0, right? So that's why it can't be invertible. Okay.
Okay, sir. Got it.
The best thing is if you want to draw it, if you have the, you can draw it and then check whether the system is 1, 1. Like draw a horizontal line. If it's just cutting at one place, you can just say that this is an invertible function. Huh? Okay. So I hope
Okay,
this is
sir.
clear to everybody. Yeah. Is it clear to everybody? Everything, whatever we have discussed, you can just practice 2 questions. Okay. And also, this differentiator is in invertible or non-invertible or integrator? What about this? Invertible or
Not
non-invertible?
in, not invertible.
Not invertible. What about the the integration? The integration is the integrator is invertible because for every output you can trace back the input. Okay, so you can see that xt you can just put. Let's for example you're putting some constant value. The constant can be n number of values, right? You'll be getting the same output. So that means what? From output you can't trace back the input. But whenever you integrate, right, for different integrator, for different input you'll be getting a different output also, right? The integration can't be same. Okay, and I'm talking about this integration minus infinite to t. I'm not talking about the area and all. Is it clear to everybody?
Yes, sir.
Okay. If this clear, then I hope I don't think so you'll be doing any error, any mistake in the exam. Okay. And all the best for exam. We'll meet. I'll be having one more session. I'll discuss the Fourier series. I'll just tell you how to just deal with, like, quickly solve those type of a questions without using the like formulas. Of course, you'll have to use, but at least from the options, how can you to get to the final answer correctly? Huh? Okay. Thanks. Thanks. Any doubt anybody has in any of the questions that we have discussed today?
So not in them, but I have one doubt in activity question. Activity 5.3 question number 2.
Activity 5.3. 5.3, question number
2.
Okay, what is that? Okay, so is this system memoryless? This is what the question you're asking, right?
Yes, sir.
Okay, what's the doubt here?
So how we are able to tell that
So
if
this
it is memoryless or not?
memoryless, like it should just be present in the present, like it should be just be present, right?
Yes, sir. So, but there is we have integration and differentiation, all things also, right? So will that affect?
Okay, yeah, that will affect load. Let's for example, this is a differentiate, right? So what happens if you differentiate something? Let's for example, you just take some input. One input can be. Let's for example, you take some input, some constant. If you take it. Hmm, 3t, right? Just give me, okay, let me write it. Okay, so see, let's for example, this will for sure needs memory, I guess. This will need memory. Why? Because you have a differentiator in YT also, right? So if you have something in YT, let's for example, you have something, you're differentiating YT itself, right? So if let's for example, you have to get back the YT. If you have to get back the YT, you will have to integrate the remaining combination, right? If you are integrating, that means what? It will need some memory to store, right? So that's why it will sure need memory. So this is a system with memory, I guess. Are you getting me?
No, sir.
No, wait, I'll write it. Okay.
So your screen is not visible.
Yeah, yeah. Now is it visible now?
Not yet.
Is it visible now? It's visible, right?
Yes.
Okay. Yeah. So the given is d of yt by dt. Let's for example, the question was just this one. Okay. So to get back yt, you'll have to integrate xt, right? Huh?
Yes, sir.
To get back yt, right? So the equation here is this out. There should be some combination yt in the form of input, right? So this is memory or memoryless. You need some memory, right, to store from minus infinite to t, right? So this is not memoryless for sure. Are you agreeing with this
Yes,
or
sir.
not? Right. Now the same here also the same thing is there. So you have differentiation of yt, then plus some 3t yt, then you have t square dxt. So here again, if you need this yt, right, you'll have to integrate something xt in the form, right? So you'll be having you need some memory to store because the yt to get yt will be in form of some integration. So I hope that is why this question has been framed in this way. So that's why you need some memory. This will not be a memoryless function for sure.
Okay, sir. Got it.
Okay. Yeah, you got it right. Okay. Yeah, what Sonali is saying, I can't see that. As regarding the future value can be stored or not, I'm not very sure about, but so far as I know, because she said she can't store the future value. It's, I don't know what. Yeah, can you tell me what? Okay. So if you have a doubt, you can just let me know. I just talking about the static and dynamic. I guess you were talking about, right? I was saying that static is also known as memoryless, because you're just dependent on the present, so you don't need any data to store. Like, you don't have memory because you're just present in the present. Okay? To store anything that is already past thing, right, or future, you need some memory, right? So that's why the dynamic is called it a systemic memory. This is what it was discussed, something else. Okay, so let's. Okay, anything else? Anybody, Ananya or Sonali, anyone else has anything?
No, sir.
No, sir.
Okay, so can we close this? Just let me know if you have any doubt. You can just ask me in the group. Okay.
Okay, sir.
So I hope regarding the system thing, if you have like anything that you have from week 5 to 8, any doubt, you just ask me. Okay, so I hope this one you'll not be able to. Whatever will be asked will be from this slide itself. I'll just share this slide in the group now. Okay, apart from this, I don't think so there'll be any function that will be asked as such. Integrated, you just remember. If you have understood that, well and good. If you have not, then directly you remember that. Huh? Okay. Thanks, everybody for joining.
Yes,
Bye
sir.
bye.
Thank you, sir.
Thank you.